So hey guys, welcome to the video. So today we are going to discuss this question of the bi-weekly contest of Leetcode. So this one is the second question, namely minimum operation to exceed threshold value 2. So this comes under a medium level difficulty. So let's first read out the question. So you are given a zero indexed integer array naming nums and you are given an integer k. Okay. So you are supposed to do an operation, and in one operation you can take two of the smallest integers of the nums array. So friend, as soon as you listen or as soon as you get a term like smallest integers of the array, smallest integers means minimum values of the array. So if you find anything like addressing the minimum or maximum value of the array, so the first thing that should come into your mind would be the priority queue or heaps, like min heap or max heap, because we know we are going to take out. Okay, so we are going to access those two elements. So to access the minimum or maximum element of an array, what exactly we can we can use a heap data structure for that, where we'll be storing all the element of array. So as you know, in a heap data structure, so it stores at the top of the heap data structure, there is the if it is a min heap, there is the minimum element of the array. So if you want to take out two smallest integers, that means you have to take the first two element of this heap. Okay, first two elements of this heap. Okay, now the second thing you are doing is removing x and y from nums. Okay, so as soon as you take out x and y, the two minimum values, then you remove these two, and at the same time you add minimum of this x comma y into 2 plus maximum of x comma y. Okay, so as soon as you remove these two, you just add the minimum of these two into 2 plus maximum of x comma y. So I don't know why they have exactly given this statement here. Like, if you are taking the first two smallest element, and if I'm using a priority queue here, so I know the first element will always be smaller than the second one. So I don't really need to check which one is the minimum and which one is the maximum. I already know that the first element will be going to be my minimum and the second one is going to be the maximum between these two, because these two are coming out of a min heap. Okay, so yeah, so till now only I think you must have understood the approach of this question. So after that, what I have to do is note that you can apply this squared operation nums. Yeah, so it is also true that we can apply this operation only if we have at least two elements in that array. Okay, now what we have to do is return the minimum number of operation needed so that all the elements of the array are greater than or equal to k. Okay, I have to make sure that how many times do I exactly do these operations, so that my so that the every element of my array becomes greater than or equal to k. Okay, so till now I already have told you to keep a min heap, because we are going to take out the two smallest element here. Okay, so if it is saying that we are going to make it greater than or equal to k, so friend, as I already told you, I am keeping all these elements in a heap here. Okay, all these elements in a heap. So let's say it is 2 11 10 1 3 and it is a min heap. So the elements will be storing as 1 2 3 10 and 11 here. So every time you will be accessing the top element of my heap, okay, the topmost element of the heap, you will be talking to the minimum element of my array or the heap. So if that element is, if that element becomes greater than or equal to k, so it is quite understandable that all these will automatically be greater than or equal to k, since like let's say I am considering a number 1. So if it is 1, if I am taking if I talking about the first element of this heap, and after taking it out, we are saying that the element present here is the 1. Okay, the value with 1. So it is quite understandable that all the other elements in this heap will be going to be greater than 1. As you can see here, it is 2 3 10 11. So if I will compare from the topmost element of this heap, or topmost element of this heap, and if that element will become greater than or equal to k, then I can say that yeah, you have got an answer. Like, now you can say that all the elements are greater than k. So we have to perform this operation again and again until my topmost element of the priority queue becomes greater than k. So this is quite the intuition of this problem, and this is quite how you should how the solution will be. So I could explain a solution to you for, let's say my k equal to 10 and 2 11 10 1 3 are there. Okay, let's again create a heap and put the elements out there. So I just created a heap and I will put the elements in here. Okay, so the elements will be 1 2 3 10 and 11. So do the first step. I will take 1 and 2 out. Okay, I will take 1 and 2 out. Then, and what they are saying, I will take minimum of 1 and 2 is 1 into 2 plus 2, and now I will put it again into my heap. Okay, so what it will become, I will erase this 1 2. Now again I will put 2 into 1 plus 2 is 4 here. So if I will put 4, this 3 will come at the top and this 4 goes down. Okay, so it will become like this. Now I will take out 4 and 3. First I will check the if the size of this heap is greater than 2 or not. So it is greater than 2, then I will take out 4 and 3. 3 plus 4. So 3 into 2, it will result out at 3 into 2 is 6 plus 4, that is 10. So now we will push 10 into my heap. Okay, I push 10. So as soon as I push 10, now I will just at each step I will be keep considering that either the top element is greater than or equal to say. So my k value was 10, so this becomes greater than or equal to k. So at each step I will also be keeping a variable count, which will be counting how much time I am doing these operations. So at this time the count will be 1, at this time the count will become 2, the answer will be 2. So yeah, this is how it is. Now let's quickly move on to the code. Before that, we should also understand the constraint here. So here the elements you can see are less than or 10 raised to 9. So we should keep our elements, use the priority queue by keeping the element as a long type, not as a integer type, just to have all cases passed. Okay, so yeah, now let's quickly discuss the code, I guess. Yeah, so this was which I have submitted. So I will take a priority queue. Don't forget to take a mean priority queue. For mean priority queue, you have a different syntax out here. So we have to first declare a mean priority queue. Now we will push all the elements inside the mean priority queue, and don't forget to convert them into a long type. Okay, after doing this, we will start exploring our mean priority queue here in this loop. So the condition is to for breaking of this loop is, so the size of this min heap must be greater than 2 or equal to 2, and the top element must always be smaller than k. Okay, so I will take out the first element, pop the element, take out the second element, pop the element, and I will push, as I already told you, the first element will be smaller than x into 2 plus y, and each time I will be incrementing the value of answer. Then at last I will be returning the answer, and this is the this solution works, and this is the approach that we had to use in this question. I hope this helps, and if any doubt, please leave out in the comment. Thank you.